Let us have another problem. Calculate the weight W necessary to start the system of blocks shown, considering the value of the coefficient of friction is equals to 0.10. Assume pulleys are frictionless. So we have these two blocks here, A and B, whose weights are 500 Newton and 300 Newton, and also the suspended weight W. So this is unknown. So first, let us consider the free body diagram of block A. So we draw the free body diagram of block A. So this is block A. We have the weight of block A as 500 Newton. And then we have the tension T1. And also, we draw the frictional force and the normal force. So let's call this normal force NA, and then this is frictional force FA. Now, how do we determine the direction for the frictional force? As you can see from the figure, if we suspend the weight W here, tendency for these two blocks is to move according to that direction of motion of W. So this block will move to the right. This block will move up the incline. So if this is moving to the right, then therefore, the direction of the frictional force at A is to the left. So we take summation of forces along the y-axis equals to 0. So we say that NA is equals to 500 Newton. And then from the frictional force formula, we have F is equals to mu N. So we solve for FA. This is equals to 0.1 of N, which is 500. So FA is equals to 50 Newton. And then, this time, we can take summation of forces along the x-axis equals to 0. So we have T1 minus FA, okay, is equals to 0. So we say that T1 is equals to FA, which is also equals to 50 Newton. Next, we consider the next block, which is block B. So we draw the free body diagram of block B. So this is your block B. The weight of block B is 300 Newton. So we draw the tensions on block B. So this is your tension 1. Let us call this your tension 2. And then we draw the other forces. So this angle here, by the way, is 30 degrees. So other forces, we have the normal force. Let's call this NB. And the frictional force. Since the motion or impending motion is up the incline, therefore, the frictional force is directed down the incline. Let's call this FB. So, we put all the necessary angles. So, if we draw vertical line here, that angle would also be this angle, 30 degrees. And then, if we consider the rotated axis, this is your y-axis, and this is your x-axis, that angle is equal to this angle. So, we can now take summation of forces along the y-axis equals to 0. So we have N2 or NB minus the y component of 300 Newton. So that's going to be 300 cosine 30 degrees. This is equals to 0. So it follows that NB is equals to 259.81 Newton. So we can solve for the frictional force FB from the friction formula. So we have FB is equals to mu, which is 0.10 times 259.81, the value of NB. So FB is equals to 25.98 Newton. So we can now take summation of forces along the x-axis equals to 0. So along the x-axis, we have T2 or T2 minus T1 minus FB minus the x component of 300. We have 300 sine 30 degrees equals to 0. We have the value for FB, 25.98. Value of T1, 50 Newton. So we can now calculate for the value of T2. T2 is equals to 225.98 Newton. So if we consider now the last free body diagram, which is that suspended weight, we have the weight W, and then this is your tension 2. Take note that this tension here and this tension here are the same, since pulleys are assumed to be frictionless. So this tension is equals to that tension. So we say that if we take summation of forces along the y-axis equals to 0, we have W is equals to T2, which is equals to 225.98 Newton. So we get that final answer.